Julian. I've chosen this title, 5G is more than just cellular, in a way to encapsulate the way that we looking at the 5G, even though the name is with a G, is a generation and has a connotation that it is like 2G, 3G, 4G. But it is just more than the cellular system, the way that we have been designing the previous generation standards, and is always about, or the way at least in 5G Innovation Center we look at it, is about always sufficient. It's not necessarily differentiating 5G from previous generation system, yet by higher speed. It's more than that. I believe that the 5G will set a new paradigm of thinking, the way that we need to move on from the 30 years of the design of the mobile system, which was based on 2G system. Now it is a time for 2020 and beyond 2030, and etc. We need to start think differently. So I would like to acknowledge our industrial partners. As you can see, the names, as well as the Higher Education Funding Council of England for funding this activity, which was the first in the world, to our knowledge, and also some of our partners like Connected Digital Economy Catapult, E3, the National Research Center from Taiwan, and also Enterprise M3 Local Enterprise Partnership are amongst the partners we are working together. The diversity of the partners that you can see, the telecom operators, vendors, regulators, as well as the broadcasters. In a way, it indicates the focus of our research towards 5G. Is it the right time to start working on 5G? It looks like if you follow the trend from 1G and in UK system, tax analog system, to 2G, 3G, 4G, it looks like about roughly on average, every 10 years, the new generation has to come. And that is preceded by about 5-6 years of at least research and standardization. And if we believe in this trend, it looks like even us, 5G Innovation Center, which is the first one in the world, we started working on dedicated center on 5G. We were one late behind the schedule. So we should have started work on 2011. And it is very important to know that the new generation system that come do not replace previous generation system, but they tend to coexist and work with the previous generation systems. And another important observation to make is the time between generation seems to be shrinking. 12 years, 10 years, 8 years, and we expect by 2020 the 5G will be commercially available, 2020, 2021. And there's another important thing is to emphasize here is the system, 5G plus other generation system, they have to serve the market not only for the traffic we expect in 2020, but at least 2040, 2030, 2040. So we need to be clever enough to project and predict what is going to be, at least from the traffic requirements and the diversity of the services, and then design the system based on that. To us, unlike previous generation system, we do not want to design the system for voice or data, and a little bit of voice and more data or more data alone services. Everything on internet is important. Every application, low data rate, low latency, high availability to broadband is important. So it is very important to not to design 5G for a specific service and with specific requirements. What is important, the flexibility and scalability of the system in order to incorporate the future requirements. For us, again, we believe that future is in connectivity. Connectivity between people as well as connectivity between devices. Connectivity between people, we have witnessed that one from 1G to 4G. And in addition to communication between people, the control towards digital economy, utilizing the ICT technology for modernization and transformation of the other adjacent industries like transportation, energy, manufacturing, health, towards smart homes, smart cities, and smart countries. So connectivity is the key. So I start with the control side, right, and then we look at the communication side. Control side comes from the Internet of Things, which is not only about connecting devices of a small, low power, low energy, whatever, or low bandwidth devices, but it is small devices to large devices with different capabilities, and ranging from robots, cars, sensors, and more importantly, something that we do not pay enough attention to is the actuators. When we talk about IoT, everybody more or less talks about sensing and collecting data rather than what you do with this data in terms of control and actuation of that. Smartphones all the way to driverless cars, all needs to be connected. The major functionality, again, I mentioned, is sensing, data analytics, and if not more important, but at least equally important to sensing is the actuation, what you do with that data. So I would like to bring this to the research community to emphasize more on the actuation side, or at least as much as we do on the sensing and the data analytics. So this modernization and control aspect of the 5G is being said that 2020, 14 billion connected devices from the education, from health, from the smart fridge, smart home, and the smart cars, and etc., and e-health are already connected to internet. And it's been said that is only 1% of all the potential devices that could have been connected is already connected. So there is a room for 99% more of these devices to be connected in a digital economy and connected society. So the major challenges here is, it's been mentioned, is latencies. And especially when we are talking about actuation and control, reliability is extremely important. Security, privacy is being emphasized enough, and we cannot emphasize more on that, as well as the energy consumption of such networks. If we project the future, that the communication and internet would evolve to be the platform that connecting other adjacent industries, like from electricity, water, food, and other networks connected to this one, then the communication and internet become a supranational critical infrastructure, and the security and reliability of such systems are extremely important. So reliability is probably as important as the latency to justify the 5G system. And if we have this connected industry with each other, the impact of this connectivity of manufacturing, retail, health, all the way telecoms, and etc. to UK economy is 10 times compared to what we have today. And that has been reported. But the important thing is the data is generated on their own. I know we talk a lot about the big data, but we do not need a massive and huge amount of data to make sense out of things. Sometimes with a small amount of data, and we can get lots of useful information. So, and data analytics is by connecting of the data, different pieces of data with each other, and extract meaningful patterns. That is a challenge. Extracting meaningful patterns from this data, which can be translated into the actuation and the intelligence that we want to provide. And that is an aspect that we are not really paying enough attention, research-wise, as well as from our industry. I'll give you an example on what we can do with data. A couple of my students in August to November 2013, they collected about 8 gigabytes of data in San Francisco Bay Area. It's the tweets that everybody sends to each other, not anything for particular incident or event is happening. So it's about 8 million tweets and over 182 million sensor data points were collected. And we compared this data, we analyze it, we fuse them together, and we interpret it, we cut a pattern, and compared it with the road accident or incidents in San Francisco Bay Area, which compared it with the geolocation and the hash location of the data and the time, so location as well as the time of the incident is happening. So 511, which is the service for road traffic in US, they reported 170 incidents happening from the Twitter that normal people transmit to each other for different reasons. We extracted 311 incidents, and much quicker than 511 could announce or declare these incidents. And there wasn't a huge amount of data, but the pattern recognition and correlation of the event with each other was sufficient to see what is going on. So this is the pictorial representation of the incident. So visualization is very important as well of this data. So now we got to pay attention to the communication side, which is another part of the 5G system, is mobile broadband cellular beyond 2020. You've seen these reports that people saying that the traffic in 2020 compared to 2010 will be 1,000 times more, the mobile data traffic. But as I said, we are not designing the system for 2020. We are designing the system for 2030 and 2040. And if the pace of this increase of traffic continues, we should design the 5G for 1 million times mobile data traffic, not 1,000 times. And it is very important to highlight this one. This traffic do not include the traffic generated by Internet of Things or machine-type communication, or the traffic generated from the car, and etc. It's only mobile data traffic. And looking at UK scenario, we said, okay, if we don't question this doubling of the traffic every 12 months, and etc., we said, what is the implication of that in UK mobile communication? So we scale down the global traffic to UK traffic from UK to center of London, which is a good representative of most of the capital Western countries, capital cities like Paris and Berlin, as well as other capital cities like Tokyo and etc. It's a good representation of that. So we look at the UK dense urban environment, which is center of London. And we found that the ratio, the capacity we require between 2015 and 2020, the ratio between the two is 19 times, sorry. So if we carry on developing 5G broadband segment, the way that we've done 4G and 3G, 4G, we need about at least 19 times more radio spectrum. And Simon will tell you, you've got to be joking. So we cannot carry on, even if you don't believe in this traffic, I would say it's exaggerated, we need 10 times more. If you don't believe in that 10 times more, we need at least 5 times more. And the best we can expect, amount of spectrum that we have in mobile, which is 500 megahertz, we're going to have another 500 megahertz. That's the best case we can expect. So we can not carry on designing 5G the way that we have designed previous generation system, yet by bigger pipes and more bandwidth. We don't have that luxury anymore. So we need to look at the very advanced technologies in order to utilize the spectrum more efficiently, order of magnitude more efficiently compared to previous generation systems. Sorry. So if we look at this traffic and look at the unlicensed band in a Wi-Fi system, the license, this is the mobile data traffic, and this is the effect of the Wi-Fi deployment on reducing the traffic demand. It's not that much. If we deploy Wi-Fi in a cellular deployment, the interference will kill all the capacity, put it this way. And we assume that 40 megahertz per operator typically of LTE and LTE Advanced. This is a demand, this is the capacity for different cell densification. This is the cells of 25-meter radius. And this is the cells of 50-meter radius. As you can see, most of the UK operators in center of London, they will run out of capacity before 2020, as you can see. Even with the most advanced technologies in LTE and 4G spectrum. So moving on, what we said, 5G is not about higher speed. It's not about downloading a movie in a fraction of a second. But it is about the user and quality of experience of the user, and always providing the sufficient rate to give the user perception that they are in infinite capacity environment. And that's what we want to do. And for this, we need to understand what user requires. Quality of experience is extremely important. And we don't claim to know that what it is, but this is part of our main research agenda in 5G Innovation Center in order to understand quality of experience, to capture it, and to implement it in network. Another differentiation of the 5G Innovation Center to previous generation is we start from end user quality of experience. We do not start from the network and the radio and stop at the device. But the person is using the device is more important in this equation. For human to human, human to device, as well as device to device communication. We focus on area spectral efficiency and energy efficiency, and we look at the latency from two different aspects. The latency on the radio side is extremely important. The frame structure in LTE is too long to get the maximum benefit of most of the techniques which rely on the feedback from transmitter to receiver. So that latency is important, and this is the latency on the radio side which maps to much bigger bandwidth and higher speed. So it's a good reason. It will be higher speed 5G. Our calculation has shown it will be at least 10 times faster than, has to be 10 times faster than 4G, but because of these latency issues. As well as the latency on the service level, end-to-end latency. And we are also, unlike previous generation system, we are not starting the research from macro cells and then scale it down to small cells or high density cells. We are doing it the other way around. We start from high density small cells, develop a technology, radio and networking technology, which should be scalable for macro cells. So this is another big difference that we are adopting. Since we are looking at user perspective, and quality of experience is important, user doesn't care whether they receive the service using the digital terrestrial broadcasting or cellular system or a Wi-Fi system is a license or license XM bands. Because all of these systems, they provide data, video, and audio. So user, as long as the price is right, it does not care which system is receiving the information. So why the regulators and us research community, we differentiate between these systems. So the system 5G should work in license and license XM bands. So we are looking at taking the data utilization and pattern recognition to provide that intelligence control in the 5G in order to provide that perceived infinite capacity. And I will not go through this one. We need a new air interface. We need a new radio access network architecture. We need a new fixed network architecture as well. And most of this is to provide reliability. We are distributing most of the intelligence and functionality between device and the network, rather than being like 4G, everything is network-centric, and previous generation system. And we are looking at the advanced technique like full duplex radio, and etc. So I'm going to skip this one. That is generally shows the approach we are taking. We need higher speed? Yes, we need higher. It will be higher speed, even though it wasn't our prime target, for 3 different reasons. One is the low latency on the radio side. The second one is quality of experience. There's a certain time that if the user requires the service, it should receive that. It could be low data rate, or it could be broadband service. And the third reason is this. Believe it or not, GSM was the only system that provided higher speed compared to fixed. 9.6 kilobits per second modem at that time. Ever since then, the gap between the fixed data rate and mobile data rate is getting larger and larger and larger. We cannot let this one happen. We need to reduce this gap. We are not going to have the same rate as the fixed network, but we need to reduce this gap. That's the third reason for that higher speed. Energy is very important, energy consumption. The size of the total pie for energy in today is this side. 2020 will be 1,000 times more. 2030, the size of the pie will be even larger. We cannot carry on doing that, especially when you look at the energy consumption. Most of it is used when the network is in standby mode. A small amount of it is used for data traffic. So we need to come at techniques, a solution based on a software-defined networking principles extended to the radio side, so we can save on the energy consumption. Not only when it is no traffic in a cell, but also we need to revise the signaling architecture in order to save more energy. Because we had a presentation from ITU, and ITU normally sets the requirements for the IMT 2020 and 5G, etc. My plea to this organization is don't set 5G by yet another higher speed. It doesn't make sense. But set these requirements, so industry will come up with this. Sorry. How many bits per second per meter squared we require for 5G? Set that target, industry will come up with solutions with that. What should be the bits we can transmit per joule? Set that target. Latencies that should set, end-to-end latency as well as over-the-air latencies. And we need to understand what is quality of experience as well. So in 5G Innovation Center, we're doing this research, advanced research, but it's not going to be just a paper study. We plan to, by April 2015, we will have the 4G advanced, 4G LTE advanced network infrastructure provided by our industrial partners. And it's an end-to-end network from Newbury, Vodafone, all the way to Guildford. And then we gradually modify this testbed, which is over an area of 4 kilometers squared, covers urban, suburban, rural, as well as the high-density Guildford High Street, and to test the new advanced technologies. And see all our partners providing the cloud infrastructure, and Ofcom together with Vodafone and British Telecom, giving us permission to use their 2.6 gigahertz bandwidth spectrum, and together with the EE with the wireless backhaul, and as well as Huawei. So we believe that 2016, middle of 2016, or etc., the standardization for 5G will start, will ramp up, and it will be available by 2020, 2021. At least 5G phase 1 will be available. And based on this, we have planned our own activities. We do advanced research, we do testbed emulators in the lab, and then we take it outside to do real environment testing of the technologies. Okay, just to summarize, 5G includes all other national critical infrastructures, not only mobile broadband. And these are some of the areas that we said is very important: latency, energy efficiency, scalability, and etc. And we set ourselves a target. What we are going to do, we want the system to be 100 times more energy efficient than 4G. Availability of 99.999 at least for the network, machine-type communication, and it has to be 10 times faster than 4G. It includes the digital terrestrial broadcasting and other more intelligent systems. So I'm pleased to say that I announced in ICC in Sydney that we have a breakthrough technology that we can achieve 0.1 terabits per second, 100 gigabits per second. And I'm pleased to say that my researchers said to me that we can do 200 gigabits per second in only 100 megahertz bandwidth. So that means a spectral efficiency of 2,000 compared with a spectral efficiency of 4G LTE, which is 4, in 100 megahertz bandwidth. And I want to show you an example of how you capture some of the intelligence based on a very limited amount of data. This refers to the data is available from the sensors in a mobile device in order to capture the user context. Can I? Dan?
We've created U-Direct technology that allows us to estimate which way a user is facing, regardless of the position of their mobile device or its orientation. In addition, U-Direct is able to recognize the position of the device in real time. Knowing which way the user is facing and where the device is placed with respect to the user gives valuable information for the provision of mobile services and applications. Some of the applications of this technology include positioning applications for indoor or outdoor environments, bed reckoning, real-time user tracking, advanced human-to-computer interaction (HCI) in smart environments, real-world gaming, context-aware management of device functionalities, user profiling for real-world analytics, improved social network analysis, organizational engineering. U-Direct technology utilizes only the inertial sensors that are readily available on portable devices such as smartphones. While delivering high accuracy, our solution is able to cope with arbitrary wearing positions and orientations of the mobile device, making it suitable for use in everyday life situations. U-Direct achieves this by detecting the position of the device and estimating the user's orientation with respect to both the device and the global Earth coordinate system. This technology has a wide array of benefits in contrast to other technologies available today. These include accuracy, outperforms the existing state-of-the-art solutions, for example, GPS-based systems. Compatibility, applicable for any portable device with integrated inertial sensors. Scalability, implementable on off-the-shelf devices as a software and does not rely on any infrastructure. User-friendly, works regardless of the mobile device position and orientation on the user's body. Real-time, provides instantaneous estimation. Energy efficiency, uses only low-energy inertial sensors, 30% more energy efficient than GPS.
Thank you very much.